Hi everybody, this is Nikhil. So today I will start the concept of armature reaction in DC machines. Basically, the concept of armature reaction forms one of the heart-like concept while analyzing any machine basically. But when you talk about competitive exams like GATE IES or some Transco Genco exams, the share of this armature reaction concept will be very less. Hardly you can find one question, but that too not even on the numerical side but on the theoretical side. In this series I will try to cover almost all possible models of whatever the possible MCQs could be there, probable in any exam, maybe SSC exam or some state level exam or some AE exam whatsoever. We will try to cover all of them, but apart from that there is another important aspect to study armature reaction in much more detail. That is to understand the upcoming processes or upcoming topics in DC machines like commutation and all such sort of things. And another thing is that especially for interviews, if you are appearing for some BARC interview, DRDO or some Department of Atomic Energy based interviews will be there for diploma students or for BTech students also. There also some questions will be asked. There are some questions asked earlier for interview on this armature reaction concept. Why? Because this armature reaction itself becomes a heart-like concept of studying a DC machine. Understood? And also if you are preparing for SSC JE exam, paper 1 will be an MCQ generally. Paper 2 will be a conventional type. In conventional type, your weightage will be given almost like half for the numerical type of questions and half will be for analytical or theoretical questions which will be mainly analytical basis. That means which actually makes you to think. So indirectly he is doing interview there in the form of that question in conventional paper. So there also it will be helping you a lot. So therefore we will try to see in a much more technical manner and it would be very easy also. Right. So we will start with the armature reaction. Right now you need not write anything else which is there on the board. This I have already written in the Telugu version of this video. I have recorded the Telugu version earlier, then I have written. Anyhow, I will be telling you in that way only you will be writing. Don't write down as of now. So now the topic is about armature reaction. Now what is armature reaction? Armature reaction, split it into two. You have armature and then reaction. Then you will understand that some reaction is happening because of armature. Means armature is doing some reaction. So basically if you talk in our regular life, day-to-day life, what will happen? Let us say I am going to hit you on your face. What you are going to do me? You are going to hit me back. So I am doing action, you are going to give me reaction. Newton's third law. Right. See, in order for some reaction to happen, there should be some action. Without some action, can there be any reaction? No, that is not possible. So, you are having a reaction means there must be some action. Now, for machine, for this DC machine only we will say, how this reaction, how this armature is doing reaction, why it is reacting without there is any action. Yes, there is an action. What is that action here? Here action would be nothing but loading. If you apply load on that particular machine, generator or motor DC, then the armature is going to do some reaction. It is going to do some reaction. Let us say generally these two possibilities are there. That is, if I hit you, one possibility is that out of that anger you will hit me back, reaction. Or there is another possibility that if I hit you out of that anger, maybe you can't hit me because you respect me or you are fear of me. In order to discharge that anger, you will hit somebody else behind you. Understood? So the second case is going to happen here. What is that means? When I am going to load the armature is not doing anything to the load, but it is reacting on somebody else. So how it is going to react is the question. Now my first question is, what is the armature winding? What do you mean by an armature winding? Earlier I have in many situations I explained you, armature winding is that kind of winding, is such a winding which carries the rated current or the load current of that particular machine. Any winding which carries the main working current or the load current or the rated current of the machine is that armature winding only. Or another definition is that armature winding is such a winding in which the working EMF or the actual EMF of the machine is induced. Understood? That is armature winding. So in this armature winding, when you are loading, what is going to come in this armature winding? Load means current is going to come. When armature winding is carrying some current, what is going to produce? Armature flux is going to come. Armature flux is going to come, let us say that is phi A. But already there is another flux in the DC machine before you load it also. What is that flux? Let us say this is our 2 poles, a simple DC machine. This is the stator poles. Already stator poles are there, and stator poles are releasing some flux called as main flux. That is the already existing flux. Main flux is the already existing flux. Now the armature winding which is on the rotor, after loading it is going to get some current and then flux. But already existing current is main flux. Now this fellow which has come now due to loading, instead of reacting on the load, he is doing what? Reacting on the already existing main flux. That is what called as armature reaction. Armature reaction is the reaction of the armature flux on the main flux. Okay? The reaction of armature flux on the main flux. That is what called as armature reaction. Next, before going into this definition and all, please don't write down anything else right now. There are a lot of things, lot of background I have to give you before going into this discussion. So, okay, right. So there is one hero and there is one villain. That is when the fighting is possible. So that's what here happening. Here armature flux is apparently fighting with the main flux. Fighting with the main flux. Okay. And now we will see in which kind of machines or in which machines, where do we actually find this phenomena of armature reaction? Is it limited only to the DC machines only, or is it found in any other machines also, is my question. Now, what is my question? Is it present only in DC machine or elsewhere? So the question is, where do you find armature reaction in general electrical machines? So where do we find means the answer is armature reaction is a phenomena that is strictly restricted to double excited machines. Double excited machines. So what do you mean by double excited machines? Double is okay too, machine means machine only, excitation. Already you might be also knowing, I have already discussed a number of times, what do you mean by excitation? Excitation is nothing but it is a process of providing magnetic field electrically, means electromagnetizing some part and producing the magnetic flux thereof. So excited machines means double excited machines means that machine is having two sources to produce magnetic flux, means two fluxes are there. Just like you see here, you already had what? One main flux is there and newly armature flux is there. So two fluxes are there. Why? Because see, as I was telling you, armature reaction is nothing but it is a fighting. It is a war. For a fighting or for a war to exist, for a cinema to exist, there you need one hero and a villain. If you have in a movie only a hero, that is not going to make any movie, isn't it? Similarly, in order for this armature reaction to take place, two fluxes are required in which one is acting, other one is reacting. Understood? So double excited machines are required. Can you give me the examples for what are double excited machines? Just now we have seen here you are having a armature flux and main flux. So obviously I can tell DC machines are one example for double excited machines. Any other examples? Yes, synchronous machines. Synchronous machines also form part of double excited machines. Synchronous machines, how can you say that it is a double excited machines? Yes, I can tell. Let us take a three-phase alternator. What do you have in a three-phase alternator? Stator supplied with a three-phase supply, and the three-phase supply will produce a rotating magnetic flux. Next, on the rotor side, what you are having? Two slip rings connected to a DC supply. So DC supply on the rotor, AC three-phase on the stator, producing two fluxes fighting between them, etc, etc, etc. So synchronous machines also double excited machines. So this armature reaction phenomena is found in DC machines as well as synchronous machines. Next question is, basically when I ask, do we find this phenomena of armature reaction in DC motors or synchronous motors? I have heard from a couple of students saying that no, but the answer is wrong. As you see, I am telling you, DC machine, synchronous machine. Machine means what? Combination. It could be a generator or it could be a motor. So this phenomena is available in a motor or a generator. There is no such kind of discrimination. But yes, it is present only in DC machines and synchronous machines, not elsewhere. Understood? So next, like you have double excited machines, we are also having another category of windings, another category of machines. So I am just telling out of information, not belongs to armature reaction. You also have single excited machines. You also have single excited machines. What do you mean by single excited machine? Means you have only one source of excitation for magnetic flux. For example, what you can give, all induction machines, induction motors, everywhere you have single excited machines. And then another electrical device, very important one, is a transformer. So transformer is also a single excited machine. Why? Because for transformer, how many supplies do you give? You give only one supply on the primary side, that's it. And that primary supply itself will set up the working flux in the core, and transformation action will going on. And similarly, induction machine, do you give some supply to the rotor of the induction machine? Absolutely no. You just give a 3-phase supply to the stator, that's it. So induction machine is also single excited machines, and that is the reason why single excited machines are much more powerful than others. Okay, so this is another general discussion. It's not something technical. Maybe in some other video I will explain what's that issue in that. Anyhow, so this is about double excited machines and single excited machines, and you find armature reaction phenomena specifically in the double excited systems only. All right, next you have understood where you get the the armature reaction. Now my next question is, why do you have to study armature reaction? Means what is so interesting about armature reaction? What is so interesting about armature reaction is that, so basically when you talk from generator's point of view, okay, I will be taking a generator's point of view only. So what is the generator? Generator is something which generates some or gives output. Its output is an electrical energy. So electrical energy means what? Basically a generator is a voltage source. You call it a good generator when it makes available the declared voltage outside on the terminals. So voltage, output side voltage of the generator becomes a very, very crucial parameter. But this phenomena of armature reaction interferes with that process. That means armature reaction is a major source, or is a major reason. Armature reaction is major reason for voltage drops. Armature reaction is a major reason for voltage drops, and subsequently armature reaction also tends to degrade the performance of machines, and more specifically in DC machines. Anyhow, there are some remedies also for that, and we will see. But one of the primary core reason is that it being the major reason for voltage drop in a machine basically. So regarding how do you make notes means, in the order which I am telling, so now I am telling you armature reaction is a major reason for voltage drop. You please write down. Okay, if you haven't started writing down, since this is a video again, you can go back, and I have told you about double excited machines and all. In the same order you can keep on writing. So in the which order I am telling you, in the same order you write. Don't write what is there on the board. After when I tell you to write, then write what is there on the board. In this manner we will move forward. Right? So major reason for voltage drops. Right. Next we will see in different machines what are the reasons for voltage drops. Okay, what are the reasons for voltage drops? It will give you a good understanding about some concepts. First, let me take an example of what a transformer. So in a transformer, what are the major reasons for voltage drops? In transformers we have winding. The basically voltage drop takes place in the winding only. Winding has a resistance, and hence you have a IR drop, which is nothing but a resistance drop, or simply you can tell ohmic drops. Ohmic drops you have in a transformer. At the same time, what else you have in the winding? You have a leakage reactance. So you have a leakage reactance drop IXL. Okay, so leakage reactance drop is also there. Next we will take what? A DC machine. Now tell me, DC machine, what are the drops available? So when I asked this question to a couple of students, they said that sir, only DC, because it is DC. In DC supplies, obviously the inductors does not have any effect, because XL is equal to omega L, and DC supply omega is 0. So reactance also 0, there is no reactance drops in DC machine, and hence only resistance drop is the only phenomena of DC machines, you say. But you are absolutely wrong, because in DC machine I am telling voltage is dropping means where the voltage drop matters. Voltage is dropping in the armature. Okay, in the armature. And in the armature of a DC machine, what kind of a current or voltage is it? AC or DC? It is absolutely AC. It may be a DC machine, it might be called as DC machine. It is only DC machine or DC motor, DC generator from the outside, but not inside. For the inside world, it is still AC. Between the outside world and inside world, there is one mediator called as commutator in a DC machine, which will translate or convert all the AC inside to DC outside. If you are supplying with some DC outside, converts back into AC and send it inside. So definitely there is an effect of AC also, and there should be leakage reactance in the armature winding also, but still I am not going to write the leakage reactance now. The reason being, for a DC machine armature winding design, the inductance will be kept as low as possible. Inductance will be kept as low as possible, and hence the effect of leakage reactance also will be very less. And generally in analysis of DC machine, large signal analysis of DC machine, we will not consider the existence of inductive reactance. Okay, so I am not going to write. Apart from that, what is going to be there? As I already told you, armature reaction is the major reason for voltage drops, and it is also present in where? DC machines also it is present. So armature reaction becomes another important component of voltage drops in a DC machine. I into XA, where XA represents the armature reactance, means it is just a mathematical model for this concept of armature reaction. Next, synchronous machines we will take. Synchronous machines, what do you have? Same winding you have, IR, and in synchronous machine it is not the design is not same as DC machine. You will have leakage reactance as well. And synchronous machine, double excited machine, it should have armature reaction as well. So you have these three components contributing for what? Voltage drops in a synchronous machine. And you would be surprised to know that this armature reaction component of voltage drop in synchronous machine accounts for around 80 to 85% of the total voltage drops. Means out of total voltage dropping takes place in the synchronous machine or alternators, nearly 80 to 85% is contributed only for armature reaction drop only, and remaining two are kids. They are nothing else in front of armature reaction. Hence I told it is the major reason for voltage drops for electrical machines. And you see here how many components are involved in voltage drops in synchronous machine. 1, 2, 3, and out of them one big boss is also there. So can you tell me how will be the voltage drops of synchronous machine as compared to DC machines or transformers? This will come as a question. Definitely highest as compared to all other machines. Which machine will have more significant amount of voltage drops? Means what? Synchronous machines will have significant amount of voltage drops. So synchronous machines are characterized by more voltage drops. If a synchronous machine is having more voltage drop, what does it signify about its voltage regulation? The voltage regulation for synchronous machines are the poorest out of all electrical machines. Simultaneously, if you look at transformer here, you can see that transformer is having least amount of voltage drops. Why? Because it is just ohmic loss and leakage reactance, and leakage reactance would be something little higher than ohmic, but it is not as high as armature reaction. So definitely transformer has got what? Least drops. Voltage drops are very less in a transformer. Least voltage drop signifies what? The best voltage regulation. So you see, basically performance indices of any electrical machine are two things. One is voltage regulation and the other one is efficiency. In terms of voltage regulation, transformer are absolutely superior, and in terms of efficiency also, transformer is absolutely superior. You already know transformer has got the highest efficiency of all electrical machines. Now I am telling you, transformer has got best voltage regulation, not highest voltage regulation. When you are telling high voltage regulation, it signifies a very wrong sense. Means high voltage regulation means more voltage drops, more variation, more fluctuation in the voltage. Numerically, good voltage regulation should be least value. And technically, transformer's voltage regulation will be not more than 10% in any worst case also. In the most worst case, it cannot be more than 10%. Even if you take a very big transformer, 400 kV transformer also, it can't go more than 10. Hardly you will find in a practical cases 5 to 7% of full load voltage regulation you find in a transformer. Understood? So best voltage regulation and best efficiency also is the characteristic of a transformer. So hence undoubtedly the study of voltage regulation becomes study of armature reaction becomes Very important. When you study only armature reaction, then you will understand what is the root cause for the problem and how can you try to minimize, if not you cannot avoid, the bad effects of armature reaction. Understood? So now we will start discussing about armature reaction a little bit. So I told you that basically armature reaction phenomena is nothing but it is a fighting between two fellows, one hero and a villain, or both might be heroes or both might be wannabe heroes, whatever it may be. So how fighting will happen? Let us say you are a hero and I am the villain, you are armature flux and I am main flux. We both are fighting. Of course, you are the hero, you want to hit me. Now, in order this fighting to happen, basically you employ two strategies. Two strategies we will be using. One strategy is that, or one technique is that in the process of fighting, your move will be, you will be hitting. You are punching me, okay? You are punching me on my face. And how you are punching me, two ways are there. One way is that first you will be hitting on my nose like this, cross. You will be crossing 90 degrees. Understood? You are hitting on my nose in 90 degrees, cross way like this. When you are hitting me like this, what is going to happen? My nose is going to bend. It is going to distort. It's going to what? Get cross. My nose ka shape is going to change. Understood? So this is one technique. Next technique is that you are going to hit me directly on my nose, head on head. Directly over the head you are going to hit me. And when you do that, what is going to happen? Now I am going to faint and fall down because I am getting weak now. Isn't it? So two techniques are there. One technique is to change the shape of my nose, and next technique is to hit directly and make me weak and make me faint and make me fall down. Understood? In the same way, the armature reaction, the armature flux also fights on the main flux in two ways. Hence we say that it has two effects. Now you can write down the definition of armature reaction. Armature reaction is the reaction of armature flux on the main flux. It has got two effects. What are the two effects? First effect is called as cross-magnetizing effect. Okay? Cross-magnetizing effect or distortion effect. Now, from these words only you can understand what will armature flux do with the help of cross-magnetization or demagnetization. You will try to change the shape of my nose. What is my nose? My nose is the main flux. So already prior to coming of this armature flux, already there is this flux is there. This main poles are there, the flux is there, it has been distributed uniformly in the air gap. After coming of this fellow, now he will try to change the shape in some or the other manner. We will see how he is going to shape and what all in the next video anyhow. So one strategy is that you are going to do this. Next is hitting straight on the nose, doing what? Demagnetizing effect. Demagnetizing effect also called as weakening effect. Understood? So these both are the effects of armature reaction. Now here there is a very interesting question you see here on the board I have written. This is probably can be asked in interviews also. It's a very analytical and very interesting question. At the same time, like I told you in SSC JEE or IES conventional papers, IAS civil services conventional papers also, they usually tend to ask analytical questions, theoretical, if not when they are not asking that numerical type of questions, and you hardly find direct theoretical questions, and mainly it will be of analytical type only. I am asking you in that line one question. I am telling that can you avoid cross magnetizing effect or demagnetizing effect? Because now I understood that because of this armature reaction, the performance of the machine is degrading. We are getting voltage drop and the performance is getting down. The performance is getting degraded. Is there any way that I can do to avoid completely, what I am telling, completely cross magnetizing effect or demagnetizing effect? Okay? Or any of them or both of them. Completely armature reaction in a DC machine to improve performance. And out of this both, can we eliminate completely anybody? What I am telling, I am telling I am telling you in terms of not curative, in preventive terms. After something has occurred, you take medicine and it will go. That's not what I am asking you. That's what is already present in your textbooks. In your textbooks, you will be given cross magnetizing effect, ways to neutralize cross magnetizing effect, demagnetizing effect, how to neutralize or reduce demagnetizing effect. I am asking you, how can we avoid it in the first place? Okay, can we avoid? I'm not telling how do you mitigate the effects of cross magnetizing effect or demagnetizing effect. There are both different terms. Okay, so before I start my next video, I request all of you to just give me the answer for this question, and please put down in your comment box. Okay, then anyhow in the next video I will proceed with the further explanation about the entire armature reaction phenomena. Then you will get to understand what actually this question will answer, means what would be the answer for this question. Okay guys, thank you for watching, and don't forget to like my channel or subscribe my channel and share this video if you find this helpful. Thank you for watching.